We can think about radicals that are also more stable. So let's do another example with the molecule nitric acid. So we can, again, draw the skeleton here. And just by looking at it, we might not know it's a radical. But as we start to count valence electrons, we should be able to figure it out very quickly, because what we have is 11 valence electrons. We need 16 electrons to have full octets. So we're left with 5 bonding electrons. We put a double bond in between our nitrogen and our oxygen. So what we're left over with is this single bonding electron, and we'll put that on the nitrogen here. And I'll explain why we put it on the nitrogen and not the oxygen in just a minute. But what we find is then once we fill in the rest of the valence electrons in terms of lone pairs, this is the structure that we get. And if you add up all of the formal charges on the nitrogen and on the oxygen, what you'll see is they're both 0. So if you happen to try drawing the structure and you put the lone pair on the oxygen and then you figured out the formal charge and saw that you had a split charge, a +1 and a -1, the first thing you might want to try is putting it on the other atom. And once you did that, you'd see that you had a better structure with no formal charge. I have to mention what nitric oxide does, because it's a very interesting molecule. Don't get it confused with nitrous oxide, which is happy gas. That's NO2. This is nitric oxide, and it's actually much more interesting than nitrous oxide. It's a signaling molecule in your body. It's one of the very few signaling molecules that is a gas, and obviously it's also a radical. What happens with NO is that it's produced in the endothelium of your blood vessels, so the inner lining of your blood vessels. And it signals for smooth muscle that line your blood vessels to relax, which causes vasodilation. And by vasodilation, I just mean a widening of the blood vessels. So NO signals for your blood vessels to get wider and allow more blood to flow through. And if you think about what consequences this could have in terms of places where they have high altitude, so they have lower oxygen levels, do you think that they produce more or less NO in their body? More? Yeah, it turns out they do produce more. The reason they produce more is that they want to have more blood flowing through their veins so that they can get more oxygenated blood into different parts of their body. NO is also a target in the pharmaceutical industry, a very famous one that became famous, I guess, over 10 years ago now. And this is from a drug that actually targets one of NO's receptors, and this drug has the net effect of vasodilation, or widening of blood vessels in a certain area in the body. So this is Viagra. Some of you may be familiar. I think everyone's heard of Viagra. Now you know how Viagra works. Viagra breaks down, or it inhibits the breakdown of NO's binding partner in just certain areas, not everywhere in your body. So in those areas, what happens is you get more NO signaling, you get more vasodilation, you get increased blood flow.